Have you ever considered what might happen if an asteroid were to threaten our planet? Did you believe such a catastrophe could occur after viewing a movie like Armageddon? An asteroid striking Earth is not only science fiction, it is also science fact. NASA's Jet Propulsion Laboratory in California maintains an asteroid watch program whose only aim is to find and track asteroids and comets that the agency believe may approach Earth. NASA has also developed the DARTS system. What exactly is DARTS, and how NASA utilized it to prevent 2 asteroids from striking the Earth? Join us as we investigate how NASA's head issues a dire warning about an asteroid impacting Earth. Consider an asteroid the size of the Burj Khalifa approaching Earth. Is there a possibility this may happen? Well, there are at least 5 asteroids on the Asteroid Watch dashboard for 2022 alone, including one estimated to be 2.5 times the height of New York City's Empire State Building. NASA has known about this asteroid 7482-1994 PC1 since 1994. 2 of the 5 asteroids, 2021 YQ and 2021 YX, passed harmlessly past Earth on January 5, 2022, at distances of 1.3 and 2.4 million miles, 2.1 and 3.7 million kilometers. But not all asteroids throughout history have missed. Craters on Earth and the Moon show that large objects have been crashing into them for a long time. Perhaps the most well-known asteroid was the one that collided with Earth 66 million years ago. An asteroid the size of a mountain smashed into Yucatan Peninsula of Mexico, leaving a crater 93 miles, 146 kilometers wide, and 12 miles, 19 kilometers deep. Scientists believe it blocked out the sun, reduced global temperatures, and ultimately led to the demise of the dinosaurs because it generated such large tsunamis and released so much water and dust into the atmosphere. Before proceeding, it is essential to understand a few basics about asteroids. Asteroids are rocky bodies that orbit the Sun but are too tiny to be considered planets. They are also known as small planets or planetoids. Asteroids can range in size from tens of miles to a few feet in diameter, and there are millions of them. None of the asteroids put together could weigh as much as the Moon does. There are essentially 3 zones in the solar system where asteroids can be found. There is a huge ring of asteroids between the orbits of Mars and Jupiter. There are almost 200 asteroids in this belt that are at least 100 kilometers, 60 miles in diameter. The asteroid belt is home to millions of smaller asteroids, and scientists believe that between 1.1 and 1.9 million of them are less than 1 kilometer or 3,281 feet in diameter. It's important to note that not every object in the main belt may be classified as an asteroid. Take Ceres, which was assumed to be an asteroid until recently, but is now understood to be a dwarf planet. Main belt comets, compact rocky objects with tails, are a new type of astronomical object discovered in the past decade. Some of the tails may actually be comets disguised as debris from collisions or asteroid fragmentation. It turns out that asteroids are really old objects. They date back to some 4.6 billion years ago when our solar system was still forming. Early on, Jupiter's birth blocked the formation of any planetary bodies in the void between Mars and Jupiter, leading to the collision and fragmentation of any tiny objects already present there into the asteroids we know today. Although some of the biggest asteroids, like Ceres, may be fairly spherical in shape, the vast majority of asteroids are irregular in shape. A common feature is the presence of pits or craters. As an example, Vesta features a massive crater that is around 285 miles, 460 kilometers in diameter. Asteroids spin and tumble rather unpredictably as they travel in their irregular orbits around the Sun. There are more than 150 asteroids known to have a tiny moon orbiting them. Some of them even boast 2 moons. Asteroid systems with 3 bodies orbiting each other are also known as triple asteroid systems. Asteroids that orbit the Sun at a similar distance to Earth are called NEAs. An asteroid's orbit is compared to that of Earth to determine its subclassification. For example, Amor asteroids approach Earth's orbit but stay just in the region between our planet and Mars. The orbits of Apollo asteroids intersect that of Earth, although they spend the vast majority of their time outside of it. Some asteroids close to Earth are considered PHAs, or potentially hazardous asteroids by astronomers. These boulders have a diameter of more than 500 feet, 140 meters, and travel within 4.65 million miles, 7.48 million kilometers of Earth's orbit. More than 27,000 Earth-approaching asteroids have been identified by scientists. Around 10,000 of them have diameters more than 500 feet. Is it possible then that an asteroid may crash into Earth? If you want a short answer, then yes. Asteroids and comets have repeatedly crashed into Earth ever since the planet formed, some 4.5 billion years ago. Any asteroid larger than a quarter of a mile in diameter poses a threat to Earth. The amount of dust stirred up by such an impact would be so great that it would essentially produce a nuclear winter, severely impacting agriculture throughout the planet, according to researchers. Even smaller asteroids can generate disastrous tsunamis if they hit a city. Rocks from space with a diameter of less than 82 feet, 25 meters, are highly unlikely to survive their entry into Earth's atmosphere and will likely be burned up. In 2013, an asteroid exploded above the Russian city of Chelyabinsk, causing a shockwave that wounded 1,200 people. It is believed that the space rock was around 65 feet or 20 meters broad when it penetrated Earth's atmosphere. The question is, how can we prevent an asteroid from killing everyone on Earth in the future? Or are we powerless to stop an oncoming asteroid and must instead watch in horror as it wreaks havoc on Earth? With his latest innovation, Elon Musk has made it possible to turn Mars into a habitable planet. To protect themselves against an asteroid strike that may wipe out Earth, he thinks people should relocate to Mars. He thinks 1 million people living on Mars could maintain themselves. His latest project involves constructing a spacecraft to transport his volunteers to Mars. However, Musk's idea will need massive investments of dollars and groundbreaking innovations in technology. While Musk's solution requires evacuating a hypothetical impending asteroid's path, NASA's approach has already engaged an asteroid just last month as it neared Earth. What was their solution? DART, or Double Asteroid Redirection Test. What should we do if we discover a catastrophic asteroid on a collision trajectory with Earth? There are several deflection strategies ranging from extreme, a nuclear explosion, to harmless. A heavy spacecraft uses gravity to nudge the asteroid off course. Somewhere in between is the kinetic impactor technique. The principle is straightforward. To alter the asteroid's orbit and keep it from threatening Earth, we must slam a spacecraft or many spacecrafts into it at tremendous speed. Small nudges can add up to major changes in the long run, which is why this method is most effective when applied well in advance. What did DART do? Double Asteroid Redirection Test, DART, was the first space mission to test this and other asteroid deflection techniques. In November 2021, DART was launched, and by September 2022, it had reached the nearby asteroid Didymos. The spacecraft crashed onto the asteroid's tiny moon, Dimorphos, on purpose on September 26. If the accident altered Dimorphos's orbit around Didymos as predicted, it would be evidence that the kinetic impactor method is effective. Among the many suitable DART targets, Didymos and Dimorphos stood out. Didymos is barely 780 meters, a half mile broad, while Dimorphos is only 160 meters, 525 feet across. Yet they appear to pass in front of each other as viewed from Earth. Dimorphos and Didymos appear as a single point of light to optical ground-based telescopes, and the interval between their brightness variations should have altered following DART's impact. In addition, Didymos and Dimorphos do not approach Earth close enough for DART to mistakenly send them hurtling into our planet. The European Space Agency will send a probe dubbed Hera to Didymos and Dimorphos 2 years after DART's spectacular encounter on Dimorphos. Scientists will be able to examine the impact crater left by DART and learn more about the mission's significance. Just how did DART operate? DART was a small spacecraft before it crashed into Dimorphos. A box measuring less than a meter on all sides formed its central structure. 2 retractable solar panels expanded the spacecraft to a total width of 12 meters, 40 feet. The electric propulsion system on DART released a steady stream of charged ions, which gave the spacecraft a mild but constant thrust. In November of 2021, a SpaceX Falcon 9 rocket lifted out from California's Vandenberg Space Force Base carrying DART with it. The spacecraft completed many orbits of the planet using its electric propulsion to build up the velocity necessary for departure. Then it took out for Didymos, potentially passing another asteroid known as 2001 CB21. DART only had one science equipment, a high-resolution camera named Draco that was also utilized for navigation. It was designed after the camera of NASA's New Horizons spacecraft. DART sent a CubeSat made by the Italian Space Agency to monitor the impact on September 11th. Approximately 4 hours before impact, the primary spacecraft entered an autonomous navigation mode since it was too far from Earth for real-time control by flight controllers. The computer on board the spacecraft was able to tell the difference between Didymos and Dimorphos thanks to the images captured by Draco. And with that, it ended. DART crashed into Dimorphos on September 26 at a speed of 6.6 kilometers, 4.1 miles per second. Impact calculations suggested that Dimorphos's orbit around Didymos would shorten by 4.2 minutes, from 11.9 to 11.8 hours. Because of this, Dimorphos will be drawn closer to Didymos. The Hubble Space Telescope and the James Webb Space Telescope snapped photographs of the aftermath of NASA's DART mission crashing with the asteroid Dimorphos at the same time. Both Hubble and JWST witnessed Dimorphos before and after the collision, during which massive dust and debris plumes were generated. Hubble and JWST photos will reveal the composition of Dimorphos and the amount of material lost in the collision and its subsequent escape velocity. This will also help scientists to learn about the best strategy to deflect a dangerous asteroid. This is the first time the two large orbiting telescopes have gazed at the same object at the same time. Both will keep an eye on Dimorphos in the next weeks and months to follow the spreading cloud of debris and investigate the asteroid's fresh surface now that the dust has been blasted away. Even though NASA was successful in redirecting the asteroid Dimorphos away from Earth, the space agency is still on high alert and utilized the potentially hazardous asteroid as a practice run for the technology that may one day be used to deflect a killer asteroid away from Earth. Let's hear what you think of an asteroid hitting the Earth in the comment section below.